Hey everyone, in this video we're going to be talking about solving absolute value inequalities. So in the last video we looked at solving absolute value equations, something like this. Now we want to be looking at something like absolute value of x less than 6. So we can ask ourselves, what are some values that satisfy that equation? How about x equals 3? Is 3 less than 6? Yeah, so that's a solution. We have that 2 is less than 6. How about negative 5? Since the absolute value of negative 5 is 5, this is true as well. We look at the absolute value of negative 6. Is it less than 6? No. Here's where the absolute value is important, because if we were just looking at the inequality x less than 6, then everything to the left of 6 would be a solution, including negative 6. So that's not happening here. The absolute value of the numbers has to be smaller than 6. There's only one thing that the solutions of this inequality could do. They have to be in this interval. That is, x has to be greater than negative 6, but has to be less than 6. Which is exactly the interval negative 6 to 6, both with parentheses. All right, so what if we had a less than or equals? It would work the same way. What we end up with is something called a compound inequality. And we can solve this the same way that we did regular inequalities. It's just that if we want to get rid of this 1 on the 2x minus 1, we have to add it to the 5, and we also have to add it to the negative 5. So we have to do the same operation to all 3 parts. And same goes with dividing. And so we get that x has to be greater than or equal to negative 2, but less than or equal to 3. That is the interval negative 2 to 3 with square brackets on both endpoints. So here's that. All right, what if the sign was going the other way? We had a greater than or equal to. So we want to see which of these numbers are solutions. 3 is not greater than 5. 5 is not greater than 5. 7 is greater than 5. The absolute value of negative 5 is equal to 5. And that is not greater than 5. The absolute value of negative 8 is 8, and that is a solution. Any of the negative numbers to the left of negative 5 are going to satisfy this inequality because they're getting larger in absolute value. Similarly, everything to the right of 5 is going to be greater than 5. So to be a solution, x has to be in one of these two green sets, namely x has to be either greater than 5 or less than negative 5. There's no way to write that as one interval. X is allowed to be in either of these two sets. The way that we write it down is with this little u, which is meant to stand for the union of the two sets. All right, example time. We're going to get two inequalities, much like we did with the absolute value equations. Either 2x minus 3 is greater than or equal to 5, or 2x minus 3 is less than or equal to negative 5. And then solve. So we get x is greater than or equal to 4 for one of our sets. Or x is less than or equal to negative 1. In interval notation, that would be and we would draw them as shown. Another quick example. Two inequalities. And solve. In interval notation, remember that this is greater than, so that's why we're using parentheses. So these are the two separate intervals on the number line. All right, let's summarize. So you have an absolute value inequality. Could look like any of these four things, at least for us right now. There's two possibilities, depending on whether or not you're talking about greater than equal to, less than, or less than equal to. So if you're talking about less than or less than equal to, you get a compound inequality. If you're talking about greater or greater than equal to, you get two different inequalities. Note that the signs get switched. So you do the solving, you come up with an interval, something that is bounded. Of course, the picture will look different depending on whether or not you are using less than or less than equal to. For the bottom, we end up with a union of what are called disjoint intervals, or non-overlapping. So the two intervals that you end up with when you're talking about greater than equal to are separate like this. We call them disjoint intervals. There's one specific case where these 2 points would overlap with each other, but we're not going to worry so much about that. And that about wraps it up for section 2.7 and chapter 2.